As I was talking about before, we're looking at this F variable, stands for frequency, and the biggest problem that we're going to have when we put um, the amount of frequency through this, that we need to produce the energy required. Um, it's going to, obviously, it's going to create some serious radiation. Um, if we're putting any kind of biological entity through the Stargate, there probably will be some hazards. Um, and it'll be an issue. It'll be a safety issue. But there is a way that we can get around this little problem. The easiest way is going to be to surround the coils with a heavy oxide, a very heavy oxide. So some ideas that I have in mind are going to be uranium oxide. It's very, very heavy, and yeah, it can deal with a lot of energy incoming. Um, okay, so we got a little bit of radiation hazard, but we put some dielectric around it to contain it. It's not really going to be a problem, that big of a problem. One thing that we will have a problem with, maybe possibly, is going to be the limitations of this dioxide. Obviously, we're going to be using a heavy metal. Um, it's going to be able to store a massive amount of energy. Um, and if you've ever messed around with capacitors, that's basically what we're doing. Is a ceramic capacitor will only be able to be charged to a certain level. If you charge it up into its maximum potential, maximum energy density, and you keep charging it, the electrons are going to become so highly charged in there. There's going to become mechanical stress on that ceramic. Once you pass a certain mechanical stress level, um, the energy is going to force the capacitor to release that energy. And what that's really meaning is you're going to end up with a bomb, a capacitor bomb, with a massive amount of energy. Obviously, once this capacitor blows, all of that energy is going to be released in a single electromagnetic pulse. If you have a large Stargate device or a large wormhole device, you are going to have a problem. First, there's going to be a massive explosion. There's going to be a lot of force throwing these ceramic, these metal files or these metal particles all over the place. In addition, you're going to have a massive magnetic pulse, EMP, just like with a nuke. So the amount of damage that can be happened if you overcharge something is going to be bad. So that's one thing we have to look out for. But there's another good side effect, I suppose you can call it, to this. And let's say if there's some kind of disruption in the power supply feeding the Stargate, that will, this capacitor material will be able to feed the coils for maybe just a few seconds before it destabilizes and the whole thing shuts off. Okay, but that's that's really all we need to know about the distance calculations and the energy requirements. There is something else that we will need to talk about when we're going to be talking about interstellar Stargate systems. And that's where it gets really, really into the deep nature understanding understanding kind of thing. The meaning of life, I suppose. As we are all small universes inside of each other. Okay? If you have any questions, please let me know. Thanks for watching.